Today we're going to finish up the different parts of rational functions and a couple other key features that we didn't get to yesterday. What this is going to do is allow us to be able to graph them come tomorrow. Again, starting or finishing up, let's finish up page 1. We talked about x and y intercept. So x and y, they're kind of opposite of each other. Another kind of asymptote, the opposite of vertical asymptote. So we have imaginary vertical lines. We can also have imaginary horizontal lines. Okay. Now there are several rules. If we were in a class setting, what I do, I give a table a whole bunch of polynomials, or a whole bunch of rational functions, and say here, like, compare them, find some similarities, find some differences of them, etc., etc. But since we're not or we don't have that luxury, I'm just going to give you the rules flat out. Y is equal to 0. Okay, when the degree of the top, okay, is less than the degree of the bottom. Okay. You have no asymptote when the degree of the top is greater than the degree of the bottom. To say you have no asymptote, you have no horizontal asymptote, but you do have this thing called a slant asymptote. Okay, and all of this is again, it's a line that's slanted, so it's either going to have a positive or negative slope. And then last but not least, we've had degree of the top being less than, degree of the top being greater than. Then you have what could happen when the degree of the top is actually equal to the degree of the bottom. Okay, if this is the case, you just take your leading coefficient and put them over each other. So find a degree. So for example, these would be bad examples up here. Say if I get rid of this x squared, though, and I only have 2x minus 5, this is an example where they're equal, where top is bigger than bottom, where bottom is bigger than top. Okay, so if they're equal, all you do is take the coefficient. So the coefficient of this would be 1. The coefficient of this polynomial down here would be 2. So your horizontal asymptote is at 1/2. Okay. The last really big key feature, and these are tricky, and this is what I would feel like you'll get tested on, are holes. So your asymptotes are your big things for Math 3. Okay. So a hole is similar to an asymptote. Alright, but it's just it's a dot or a point, okay? And it's open. Okay? Very, very huge right there. It's an open point on a graph. Alright, it occurs when you have a common factor on top and bottom of your rational function. What you're going to see this worded as on your test, on your exam, which I don't like it, I don't know why they just don't say holes, but like when you dig a hole, you remove dirt from something, or you remove substance from where it is and you put it somewhere else. Holes or points, there can be multiple of them, of removability, or just removable points. So again, holes, points of removability, removable stuff. When you dig a hole, you remove things. All right. So going straight to page 2. Like I said, we'll do this last one over here to start with, since it's clean and we don't have any other stuff. again, what we're focusing on today, are there any holes, horizontal asymptotes? Okay. So when I want to find horizontal asymptotes, what I do is the following. You need degree of top. So if I look at the degree of my top by itself, it will just be 1. Okay. Then the degree of bottom, okay, is 2. Okay. Now, so the degree of top, is it less than, greater than, or equal to the degree of the bottom? Because it's less than, my horizontal asymptote is at y equals 0. Now we have to see if there are any holes. To see if there are any holes, okay, you need to factor your bottom. So 2x squared plus 9x minus 18. So I'm going to go to Desmos, and again, Desmos allows me to factor pretty quickly. 2x squared plus 9x minus 18. I want the roots for solutions. I get negative 6 and 1.5. So root at negative 6 and 1.5. And then remember, this is why we did all of the theorems and changing roots to factors, factors to roots, is because now I can say if it has a root at negative 6, its factor is x plus 6, and this should be x minus 1.5. However, when I multiply these things, I get x squared minus 1.5x plus 6x minus 9. And this simplifies to x squared plus 4.5x minus 9. And this are not the same. Reason it's not the same is because it is 2 when you factored it out. Now if I distribute 2x squared plus 9x minus 18. Alright, so this is completely factored form is as follows. 2 times x plus 6 times x minus 1.5, and again, all of that is divided by x plus 6 up top. If you have things that are common, you cross them out, and you find that root here, or what was common that makes that equal 0, is where your hole is going to be. Alright. So, let's go check this and see if we did everything correctly. Again, specifically speaking about holes and horizontal asymptotes. So, divide x plus 6 divided by all of this. And then I said there was a horizontal asymptote. Again, horizontal is y equals 0 and dashed. And again, if I zoom out, or if I zoom in and I move, you see how it gets extremely, extremely close. The horizontal dash line gets extremely close, but it never touches. Again, same concept as vertical asymptote, except it runs side to side, hence the name horizontal. Alright, now I said there was a hole at negative 6. So there's a couple of ways you can do this. Again, zoom back in. Negative 6 is somewhere around in here, so I'm going to zoom in. And I'm going to zoom in a lot. And so no matter how much I zoom, I can't see it. But if I take and I go here and I put my cursor on the line, as I get close and close and close and close, you can see it actually says undefined. Now, As long as this isn't a short answer test, there's a trick you can do. If I give you options, so say answer choice A is, whole at 10, B is a whole at -20, and C is a whole at -6. Which of these work? So what I want to do is I'm going to come in here, I'm going to go to my table, and if I say there's a whole at 10, again, 10, and it gives me a value. If you notice when I was here, it gave me a dot, and the dot said undefined. Again, so if it gives me a value, it's no good. Alright, so if I go -20, it gives me a value. -6 gives me undefined, but it looks like it actually goes there. Okay. And that's the new stuff for today. Domain, if you have your vertical asymptotes, they can't be part of your domain, so it's going to be a bunch of stuff like this, negative infinity to 6, and then from 6 to 1.5, and then or from 1.5 to infinity would be my domain here. Again, so this is where it starts to get kind of tricky, kind of confusing. Again, if they give you a list of numbers, this is where your answer is going to be wrong most of the time. Okay, just test these numbers, put all of these numbers in with the exception of infinities. Alright, and if it gives you values, it must be brackets. If it gives you undefined, it must be parentheses. Again, we've already learned this stuff, guys. Okay, x-intercept, y-intercept, y'all know what it is. Rational functions, always discontinuous or non-continuous. Alright, so let's go through here, do this middle one together. So horizontal asymptote, and then holes. Again, holes removable, essentially the same thing, so don't worry about that. Degree of top is 2. Degree of bottom is 1. Therefore, I have a slant asymptote on this one. Again, if the degree of top is greater than your bottom, you're going to have a slant asymptote. You're not going to see that, but I at least want you to be familiar with it for when you see it in pre-cal. Alright, now to find your holes, if there are any, you factor the top, factor the bottom. Again, I'm lazy, so I'm going to start a new problem. I'm going to go home, x squared minus 9. I get a 0 at -3 and +3. So I have a root or 0 at 3, -3 for the top. Again, x plus 3. I also have a root at -3. And again, if they share common roots, that's where the hole is. Okay? Pretty simple. Horizontal asymptote does not exist. Again, you have questions, email me. We'll get it figured out.